Could you explain it once more?
Yeah, 1 second, I will say the point. Where solenoidal spelling is Solenoidi. Sorry, I have written the. Mama. Hmm. Solenoidal vector. I did on the statement. Your statement is a vector point, a vector point function f vector is is said to be is said to be solenoidal if divergent f vector is equals to 0. If we are getting divergent f vector is equals to 0, that will be called as a solenoidal. You know how to find the divergent f vector. Just you have to do the partial differentiating with respect to x, with respect to y, with respect to z. Then you have to substitute back those values into that divergent f vector. If after substituting, if it's becoming it's equals to 0, those vectors are called as a solenoidal vector. Now take down the problem. Find divergent f vector where f vector is equals to r vector, sorry, r to the power of n into r vector. Find n if it is solenoidal. If it is solenoidal. What the question is saying, they're asking to find the divergent f vector. Along with that, they're asking to find that n value. And how you're going to find that n value?
Equate divergent f is equal to 0 and that n should.
Yes. Yes. If your divergent f vector is equals to 0, in that case, you're going to find the curve, right? Where your solution given f vector is equals to r to the power of n into r vector, where we know that r vector is equals to xi vector plus yj vector plus zk vector, where your r is equals to mod of r vector, which is equals to under root of x square plus y square plus z square. If I am going to square on both the side, what I am going to get, r square it's equals to x square plus y square plus z square. I will make this equals to equation number 1. To this equation number 1, I will do partially differentiating with respect to x, with respect to y, with respect to z. What I am going to get, partially differentiating equation 1 with respect to x, y and z. First time with respect to x. What I am going to get, 2r into dou r by dou x is equals to 2x, where your 2 and 2 will get cancelled. Dou r dou r by dou x is equals to x by r. If I am going to do partially differentiating with respect to y, same I am going to get, instead of x it will get replaced with y. So directly I can write similarly with respect to y I am going to get dou r by dou y, it's equals to y by r, dou r by dou z, it's equals to z by r. Now what I have to find? Divergent F vector I have to find. We consider divergent F vector, that is nabla F vector, which is given your what they have given, r to the power of n into r vector. Your nabla into r to the power of n into r vector they have given to us. So your what I'm how we can do?
I have a doubt.
Yeah.
In the previous question we did, so divergence means nabla f,
Yes,
right?
nabla f. Yes.
But then gradient,
In
yeah, ma'am,
gradient,
gradient
in gradient, you're going to have as in a what? Hmm,
only the nabla, only the triangle,
yes.
and divergence means when you're doing it with the function.
Function we are going to have not as an a vector. That is only the difference. See, this is a vector. It is f vector. This is where f vector will be denoted as an a what? Wait, I will show you what is the difference. There we are having a function, but now this is not a function. This is like a vector, f vector it is, where your f vector will be denoted as, your f vector is going to be f1 I vector plus f2 j vector plus f3 k vector. Is that clear?
Yes, ma'am. So,
Huh?
so with
And
divergence, it is a vector.
yes.
Always, it's
Hmm.
always a vector.
And where you are given f vector is equals to what? R to the power of n into r vector, it's given to us. Where you are given your f vector is equals to r to the power of n into r vector, where we know that r vector is equals to f vector is equals to r to the power of n into xi vector plus yj vector plus zk vector. Now we'll multiply this r to the power of n on both the sides. F vector, which is equals to r to the power of n into x vector plus r to the power of n into y into j vector, then plus r to the power of n z into k vector, where my f vector is equals to f1 I vector,
1 second. So f vector is f1 plus f2 plus
f1
f3.
f2 f3,
Plus,
that is a vector. There we are having a
okay,
function, it's not a vector. Here its vector will be
okay,
given. Then your
okay, okay.
f1 I vector f2 j vector plus f3 k vector, it's equals to other side we are having r to the power of n into xi vector plus r to the power of n y into j vector plus r to the power of n z into k vector. Now comparing on both the sides, comparing on both the sides. So what we are going to get, f vector, it's equals to r to the power of n into x, f2 is equals to r to the power of n into y, f3 it's equals to r to the power of n into z. Now consider your this part. Now you can, it's a clear. Now we will consider that
Yes,
one.
ma'am.
What we have to find? Divergent f vector. We have to find uh, finding divergent F vector, which is equals to nabla into F, oh god, okay, nabla into F vector, which is equals to dou F1, that also clearly I will write how we are getting that one. Dou by dou x into I vector plus dou by dou y into j vector plus dou by dou z into k vector. Then your F vector is equals to F1 I vector plus F2 j vector plus F3 k vector. It's equals to dou F by dou x into I vector plus dou F by dou y into j vector plus dou F by dou z into, no, these vectors will not be there, I into I, j into j, na, vectors will not be there, vector into vector, it will, just will get the terms, sorry, dou F1 by dou x plus dou F2 by dou y plus dou F3 by dou z. Now substitute your F1, F2, F3 values which we got from here. It's equals to, what is that is equals to? Your dou by dou x into r to the power of n into x, then plus dou by dou y into r to the power of n into y, then plus dou by dou z into r to the power of n into z. Then after that you have to do the partial differentiating with respect to x, with respect to y, with respect to z. Here uv you have to apply. Uv, this is equals to your u and this is equals to v. Similarly, this is u, this is v, this is u and this is v. The formula is what? Uv whole dash is equals to u dash into v plus u v dash. Divergent f vector is equals to n into r to the power of n minus 1 dou r by dou x into x, then plus r to the power of n into dou x by dou x. Directly I can write it's equals to 1 now. Shall I write directly 1? Aditya, you there?
Uh, yes, ma'am, I'm
Yes,
here only,
directly I'll
but
write as a 1 instead of writing this first step. Directly if we're going to differentiate that one, we are going to get it's equals to 1, then plus n into r to the power of n minus 1 into dou r by dou y into y, then plus r to the power of n into 1. That u is also over. Now with respect to z,
yes,
plus n into r to the power of n minus 1 into dou r by dou z into z plus r to the power of n into 1. Now what we can do? We can take the common from this term, from this term and this term. Combinedly we can write by taking the common as n into r to the power of n minus 1 we can take as common.
yes, ma'am.
It's equals to n into r to the power of n minus 1 of dou r by dou x into x, then plus dou r by dou y into y plus dou r by dou z into z, then plus r to the power of n I will take common. So from here what I am going to get, these terms combinedly I can write, that is 1 plus 1 r to the power of n 1 plus 1. So it's equals to what? How much it's equals to? What is happening over here? It's becoming multi. Okay. So what we are going to get from here, Aditya? Divergent
I'm still, I'm just getting confused with all the one.
Yeah. See, we are now combining this r to the power of n, r to the power of n, r to the
Okay,
power of
those
n.
three terms you're combining and the other three terms you're separating.
Yes. So we will get divergent f vector is equals to n into r to the power of n minus 1. Dou r by dou x value, what we got? From here we got dou r by dou x is equals to x by r, y by r, z by r. That we can write it's
Yes, ma'am.
equals to,
So x square by r plus
yes,
y square by r plus z square by r.
x by r into x, then plus y by r into y, then plus z by r into z, then plus 3 r to the power of n, where it's equals to n into r to the power of n minus 1 of x square by r plus y square by r plus z square by r plus 3 r to the power of n, which is equals to n into r to the power of n minus 1. 1 by r completely I will take common. X square plus y square plus z square, then plus 3 r to the power of n, which is equals to, if I will take this to the upstraight, it will become as an r to the power of minus 1, n into r to the power of n minus 1 into r to the power of minus 1, x square plus y square plus z square value is equals to r square plus 3 r to the power of n, which will become n into divergent f vector, it's equals to n into r to the power of n minus 1, r to minus bases are same, powers will be added, r to the power of minus 1, r to the power of minus 1, we can write r to the power of minus 1 will give you minus 2, then into r to the power of 2 plus 3 r to the power of n, which is equals to n into r to the power of n minus 2 plus 2 plus 3 r to the power of n, which is equals to n into r to the power of n plus 3 r to the power of n, which is equals to r to the power of n plus 3. And they are saying that find the value of f vector if it is solenoidal. This is the value of our divergent f vector. Since,
Ma'am, one second. Ma'am, that r went up and then
yes,
r
when
raised to minus 1.
this r, when it's going as an up straight, this will become as an a minus. It's because the power is positive, na?
Yes, ma'am. So
So
then
it
it
will
becomes,
become as a minus.
yes, ma'am. So it
If
becomes
bases are
n minus
same,
2.
powers will be
Okay,
added,
okay, yes.
r to the power of n minus 1 minus 1, that will become as an n minus 2, that I have written over here, where x square plus y square plus z square value is equals to r square, that is r square here, bases are same, power should be added. So again we are adding here r to the power of n minus 2 plus 2 plus 2 minus 2, it's got cancelled, plus 3 r to the power of n, r to the power of n, we will take common from here, we'll get n plus 3. Our next second half they are saying that find the n value, it is a solenoidal. So according to the definition, solenoidal it's saying as in a what, if divergent f vector is equals to 0 is said to be solenoidal, is said to be solenoidal. So we will consider divergent f vector is equals to 0, will consider divergent f vector is equals to 0. So what we are going to get, r to the power of n plus 3, it's equals to 0. Take this on this side, it will become 0, n plus 3, it's equals to 0, n is equals to minus 3. This is the method for finding the value divergent of f vector. Is that clear, Aditya?
Yes, ma'am.
Any doubt?
No, ma'am.
Did you copied?
Yes, ma'am.
Shall we move for the next one?